Hi guys, in this video we're looking at exponential graphs, and this time it's another nonlinear graph, um, but instead of x being the base, x is now the exponent, okay, which is hence exponential graphs. So let's look at what happens when we just substitute a, our base, for 2. You'll see that the line is going up exponentially, and it reaches goes towards infinity. And then what we'll see is that when we zoom in closer, it looks like that the line is tapering off and touching 0, but it never does. So what I want to alert you to is that this line, or the axis where the graph actually tapers towards 2 but never touches, is what we call the asymptote. Okay, in this case, the asymptote is y equals 0. And then I guess through the course of this video, we're going to adjust and manipulate different values and see what effect that does to the graph, so that when you do sketch or you do try to predict what's happening, you can do that because you're familiar of what happens. So let's see what happens if we change the value of a, our base value, to a 3. And you'll see that the line or the graph is steeper. And if we continued that process, you'll see that it gets steeper and steeper again as a gets bigger. Okay, so that's the first part that we can see in terms of transformations. But then what happens if we make the graph negative? Okay, so if the value of a is negative, then what we end up having is a reflection about the x-axis. So it's your vertical reflection. Here's the x-axis is your mirror line. And then obviously if we made this value bigger, we're going to have a steeper graph, but still reflected. The next one is, well, what happens if we make the exponent negative? What happens there? Well, let's have a look. We'll see that it is reflected about the y-axis. So your y-axis is now your mirror line, and there's a horizontal reflection taking place. Then obviously if we have both the a value and the exponent negative, it's going to be reflected about the x-axis as well as the y-axis. So you've got a horizontal and a vertical reflection, and if we put all four together, you'll see the comparisons from y equals 2 to the power of x. Okay, so we're looking at, once you make certain things negative, it's going to reflect your exponential graph a certain way. We've noticed that if we make the a value bigger, it gets steeper. But if we make it less than 2, you'll notice that once we hit 1, something strange happens and becomes a flat line. And you go, why? Because x is your power, and we have a base, and it should be, I guess, shallower in a sense to y equals 2 to the power of x. But what really happens, if you think about it, if you substitute x for any value greater than 1, so 1, 2, 3, 2034, 1 to the power of that value is always going to be 1. So y equals 1 makes it just a horizontal line coming through the y-axis at 1. Hopefully that makes sense. It's no longer an exponential graph. It's just a linear graph going straight with no gradient. Okay, so now we've got the next two, well, at least this one has a constant, okay? And this term, you're familiar with y equals mx plus c, and you would usually treat that as, I guess, your y-intercept or other things. But in this case, in the context of exponential graphs, you'll see that it still translates it up compared to the other. So in this case here, compared to y equals 2 to the power of x, it moves that graph 2 units up. Okay, so going 1, 2, and instead of hitting the y-intercept at 1, it's hitting the y-intercept at 3. To work out the y-intercept, you do exactly the same thing with any other graph or equation. you make x 0. So 2 to the power of 0 is 1, and then 1 plus 2 is 3. So this graph is cutting through the y-intercept or the y-axis at 3. Okay, whereas this one here has no constant, so y is going to hit the this graph, so this exponential graph is going to hit the y-axis at 1 because 2 to the power of 0 is 1. If a positive constant shifts the graph upwards, then you would think that a negative constant is going to shift the graph downwards. Okay, and that simply is what the case is here. So we've got y equals 2 to the power of x, and making that negative 2, we are shifting the graph 2 units downwards. Okay, then I'm going to leave off with these two equations here because I'd like you to be able to, I guess, predict what is happening. We have a negative base, and this negative base means it's going to reflect, and it's going to reflect about which axis? Okay, it's going to reflect about the x-axis, okay, and the plus 3 means it's going to translate the graph going up 3 units. So if we make a comparison to y equals negative 2 to the power of x, that's what it looks like in the green. And if we add 3, it's going to shift it up 3 units. 1, 2, 3. Okay. Last graph. We'll have we have y equals 4 to the power of negative x minus 2. So 4 is greater than 2. So we're expecting a steeper exponential graph. The negative x is going to flip the graph or reflect it about the y-axis, and then the negative 2 here, that constant, is going to translate the graph down 2 units. So let's have a look at that. So here is our regular y equals 2 to the power of x. So we want steeper, reflected about the y-axis, and we want it shifted down 2 units. So it is steeper than the blue, it's reflected about the y-axis, and it has been shifted 2 units, 1, 2. Okay, so hopefully that helps you. And if you have any questions, let me know. Otherwise, I'll see you in the next video.